Hello, everyone, and welcome to the session about running Cloud Foundry on Kubernetes. My name is Vlad Iovanov. I'm the technical lead for Cloud Foundry at Hewlett-Packard Enterprise.
And I'm Nikhil Manchanda, principal engineer for Hewlett-Packard Enterprise as well. And today we'll be talking to you guys about running Cloud Foundry on Kubernetes. So let me get started with this. So as part of running Cloud Foundry on Kubernetes, we recently announced the general availability of HPE product called Helion Staccato 4.0. And basically what this is an open, scalable, flexible cloud application platform that's based on Kubernetes, where you can run your 12-factor apps, your cloud-native apps. The cool thing about this is it's sort of up, as soon as you get it up and running, as soon as you bootstrap the environment, everything is sort of batteries included. So you get a Helion control plane that's completely based on Kubernetes that you can run applications on. You get a Helion service manager, which is sort of the entry point for service discovery, service binding, and comes with a catalog of applications that you can already sort of get ready and deploy. And as part of this catalog of applications, you have Helion Cloud Foundry, which is a fully Cloud Foundry Foundation certified distribution of Cloud Foundry that you can just install as soon as you have the control plane up and running. And you also have Helion Code Engine, which is a CI/CD engine for the entire lifecycle, the build, test, deploy of your applications on this cloud platform. We also have sort of a plethora of regular services like MySQL, Redis, all of that in the catalog that you can deploy. And so it's very easy to get started with it. I should mention that this particular cloud platform, Helion Staccato 4.0, supports multiple IaaS providers. So you can install it on the AWS public cloud. You can install it on OpenStack, including Helion OpenStack, which is an HPE offering. And you can also install it on vanilla vSphere. So if you have a vSphere installed somewhere, you can bring it up there and then install the control plane. And like I said, install the service manager and all of these applications that we talked about. So enough about Helion Staccato 4.0. Let's dive into a demo. And I'll show you some of what you can do with the control plane once you have it up and deployed. Give me a second here while I switch.
Oh, the mouse is trapped. There we go.
So here I have the Staccato 4.0 deployed on the AWS public cloud. And
sorry, 1 second. Apparently we have to switch. Yeah, we should move this thing here. But apparently we can't clone this thing. Okay, sorry about that.
like I was saying, so we have Staccato 4.0 deployed here on the AWS public cloud. And as part of the bootstrap of it, you can specify how big you want your cluster size to be. Here we'll just do a list nodes. And as you can see, this particular cluster has one Kubernetes master, 3 Kubernetes nodes, and 2 Gluster nodes. We use Gluster here to provide shared file system services for applications that we bring up. And when you bootstrap it, you do definitely say what your cluster size is, but you're not limited to that size. So you can grow your cluster. You can use the same HCP command line to, if you want to add another couple of Kubernetes masters for HA, you could do that. Or if you want to add nodes to grow out your cluster, if you're running a lot more applications on it, you're able to do that as well. But today, what we're going to see is actually deploying Cloud Foundry on that. And as I mentioned, the service manager is sort of the interface for folks to enter the service catalog. So we'll take a look at Service Manager and get a list of all the services that are available for us to deploy. As you can see here, out of the box, we have quite a few services that we can deploy. And the way we're going to deploy any of these services is basically we're going to use HSM, which is the client for Helion Service Manager, to create an instance of that particular service. Before I show you that, you can list all of the instances that have already been created. So if I do that, you'll see that I have the control plane as an instance that is running, and also MySQL is an instance that is running that I've pre-created. One thing that I wanted to mention here is the control plane itself, when we bootstrap, is an application that's running on top of Kubernetes itself. So it is a cloud-native application. And I'll talk a bit more about the architecture of the control plane as we progress. But let's get started with kicking off the install for Cloud Foundry. So one thing before we get to that is you can inspect any of these services to see what the actual service entails. So if this is just a very simple MySQL service, and you'll see that it has a bunch of parameters that are required as input to the service when you bring it up. You notice that some of these parameters are required, some are optional, some of them are marked as secrets. And then, so when they're marked as secrets, when you do a query on the instance, you don't get them back. And some of them are also marked as generatable. HSM is something that is very interesting because for all these parameters that are marked generatable, which tend to be secrets or certificates or things like that, you don't actually, even though they're required, you don't actually have to specify a parameter when you're creating the instance. And HSM, Helion Service Manager, will take care of actually generating these for you and populating these parameters into what we call the SDL, which is basically a domain-specific language for deploying applications in this platform. So as I said, MySQL here has just very few of these parameters. But when we talk about something like Cloud Foundry, it has quite a lot of them, pretty much a couple of orders of magnitude more than what you're seeing here. So it makes it hard to deploy if you have to figure out, hey, what does this parameter need to be? Does it have do I need to, like, more than 30 or so certificates? Do I need to generate them? How do I put this in? But since we have Helion Service Manager to make that easy for us, we don't have to specify that. And literally, in order to get a workable Cloud Foundry installation on Staccato v4, I have to specify 3 parameters. So let me go ahead and kick that off. So all I'm doing here is HSM create instance, the name of the instance ID, and the version. Another thing that you would notice here is that when you do a list services, you can have multiple product versions. And so this makes upgradability really easy. So if you're on product version, like over here, if you look at Service Console, you'll see there's 2 versions available for it, 4.0.0 and 4.0.1. If you're on one version, you're very easily able to upgrade between to the next version. Service Manager has logic that basically takes care of using this DSL called SDL, figures out whether a version is upgradable to another version, and will let you upgrade from only versions that are upgradable to versions that make sense. OK, that said, let's go ahead and kick off this create instance. OK, so like I said, 4 required values that are needed. It will prompt us to enter values for it. The service name is not required. It will generate one, but it's nice to have something that's human readable, so it gives you the option of that. I'm just going to call it HCF. the cluster password for the cluster administrator, and the base domain name that the Cloud Foundry cluster is going to use. So we've provisioned DNS already for this, so I'm just going to type that in here. And as you can see, it's off creating the instance. So since Cloud Foundry is pretty big, it involves around 30 or so pods and things like that. It takes a little while to create, so I'm just going to go back to the slides and tell you a little bit more about the architecture of the control plane that makes this happen. Okay. So as you can see here, the control plane, you can think of the Helion control plane as sort of distinctly divided into 3 types of services, microservices. They're what I call the backbone, which sort of forms the brain of the control plane. We have added services, which basically are services that the control plane brings up and uses, but are also available to other applications that get installed in this same platform. And in addition to that, we have dependencies, which are basically dependencies that are required for some of the functionality of the control plane to work. So talking about just the backbone or the brains of the control plane, we've got 3 different microservices. We have Instance Policy Manager, Resource Policy Manager, and Helion Service Manager. And I'll go a little bit into all these 3 in detail. So Instance Policy Manager is basically the microservice that's responsible for taking in the sort of API calls that are made to create an instance, or it basically handles the life cycle of that instance. So things like creates, updates, and all of that. So as part of that, what it also does is it is the interface into to Kubernetes. So all of the translation between the service definition language, the DSL that I mentioned earlier, and the actual Kubernetes definitions is done by that Instance Policy Manager. So really the brains that sort of controls Kubernetes that sits in this platform. Resource Policy Manager, the second one over here, on the other hand, is sort of the brains that controls the underlying infrastructure service. So if you think about, so this is deployed on the AWS public cloud. So when we extend the size of the cluster, we have to do a bunch of IaaS operations. We have to do things like bring up new nodes. We have to do things like create volumes, delete volumes if an application goes away, things like that. So the Resource Policy Manager is really the microservice that knows about what IaaS it's running on top of and makes the actual IaaS-specific calls to perform whatever operations are required. I mentioned the Helion Service Manager briefly before. This is the brains that is responsible for the application catalog. So it takes care of, for example, listing out the services that are available to you, doing service discovery, and also things like doing the parameter generation that we talked about earlier. In the added services piece, we have sort of 3 different added services that applications on the platform can leverage. We have user account and authentication, which is basically the Cloud Foundry UAA service, which is a fully fledged OAuth 2 provider that the control plane makes use of in the default zone. And through the SDL that I was talking about earlier, other instances of applications can also make use of this in their own zone. So if you need to do OAuth for your particular application that you're deploying on top of this, you can specifically create a zone for yourself, create OAuth scopes, groups, users, and use that. Flight Recorder is a logging service, which is basically a log drain, a syslog drain, that applications can send their logs to. and you can connect Flight Recorder to an Elk cluster, and basically that helps with sending logs from your applications out that make it easily searchable for troubleshooting and sort of manageability. Heapster is an added service for resource analysis. It's Heapster from upstream sort of Kubernetes, and so it can tell you how much memory applications are taking, and you can do a bunch of resource analysis using it. Dependencies are fairly straightforward. We use Postgres as a data store for a lot of the instance details that we keep track of in the backbone, and we use NATS as a message queue to basically just for the task system. So we create asynchronous tasks to do things, and we use NATS for that. So with that, I will hand it over to Vlad, who's going to tell you. So I spoke a little bit about the control plane. He'll tell you a bit more on the Cloud Foundry side of things. So Vlad, take it away.
Thank you. OK, so we learned about the control plane, which is this platform that sits on top of Kubernetes that helps us deploy containerized applications on top of Kubernetes. I'm going to talk a bit about how we made it so that you could deploy Cloud Foundry on top of Kubernetes using the control plane. So if you're not familiar with the Cloud Foundry, it's usually deployed using a toolchain called BOSH. And in a very simplistic way, the BOSH toolchain tells you how to organize the code in your software so that it can easily be deployed on VMs. And then after you've written your software, BOSH can also help you deploy and manage your software on top of VMs. But it's an important thing that BOSH is a solution and a good solution for VM infrastructures. But we wanted to deploy stuff on Kubernetes. So we wrote this tool called Fissel that helps us convert BOSH-like things to Docker containers. And it has this ability because we're leveraging the structure of the code that is prescribed by BOSH. So because this structure exists in all of the Cloud Foundry project, we know how to automatically compile, configure, and run all of Cloud Foundry automatically during a build process supported by Fissel. And a really nice side effect of using a tool like this is that it gives you mechanisms to make deployments easier for the user. If you just noticed, when Nikhil deployed Cloud Foundry, you only had to specify 3 parameters, which is really cool. Usually when you have to deploy Cloud Foundry with BOSH, you have many, many things to configure, and it's really complicated. And it also allows you to deliver compiled bits to the user. So usually with BOSH, the operator would compile things locally on-premise using BOSH. This way, we actually deliver images that contain precompiled bits to the customer. And the configuration mechanism is also different using Fissel. Every container that runs inside Kubernetes is actually configured using environment variables, just like a 12-factor app would. So to sum up, Fissel uses BOSH, the BOSH structure that's available inside the Cloud Foundry source code to create containers for the entire Cloud Foundry release. And Fissel creates these containers from BOSH releases because we wanted to be Cloud Foundry certified. And this containerized Cloud Foundry that you just saw deployed has been certified by the Cloud Foundry Foundation. And as you'll see, it runs on Kubernetes. So I'm going to switch back to a console. Hopefully you'll be able to see this. OK. So first, let's see if the instance was deployed. Sorry, list instances. So it's still creating right now. So we're going to have to wait a bit longer for all the containers to come up. So while that is happening, I can show you the, hopefully you can see this, Kubernetes dashboard showing the namespace for HCF, the thing that we've just deployed. Okay, so we might have a problem here. I'll just let this run in the background and come back to it later. We're doing this live, so it might have an issue as it happens.
Can you show us what the BOSH manifest looks like?
So we don't actually use a BOSH manifest. Let me switch back to the presentation. So Fissile doesn't actually use a BOSH manifest. It uses something similar. Actually, let me go to the next slide. So we open sourced Fissile a few months ago during the Cloud Foundry Summit in the US. At that point, not a lot of people were able to use it because there weren't examples for it. So today we've released CFSolo, which will serve as a component, as an example on how to containerize Cloud Foundry using Fissile. And I can actually show you the code for this. Perhaps show you what I mean by not a BOSH manifest. So if we go to the CFSolo repo, hopefully you can read this. So Fissile will expect you to have a bunch of BOSH releases and the role manifest. The role manifest will tell Fissile how you want your BOSH jobs and packages split up into multiple Docker images. In this example, we're actually building one container. So it's actually a pretty interesting project. You can run all of Cloud Foundry inside one Docker container. So you do Docker run a few things, and then all of Cloud Foundry will start up in one container with all the bits that come from upstream. So to give you an idea, you have all the jobs listed here with a release, similar to how a BOSH deployment manifest specifies things. And then at the bottom, you write some mustache templates that basically translate environment variables into BOSH property values. And let me also show you the releases that come into play for building this. So you have CF release, the rootfs for CF Linux FS2, Diego, Garden Linux, and the routing release. So essentially you build BOSH dev releases out of all of these. You feed in the role manifest, and Fissile will spit out containers with all the binaries in them. Please? Right. Right. So the question was, normally when you deploy Cloud Foundry, you have a lot of parameters. When we deployed, there were just 3. How do we handle the rest of the things that get configured? So as Nikhil mentioned earlier, the HSM part of the cloud, of the control plane that we have, has the ability to generate parameters. So most of the parameters inside Cloud Foundry, like that you need to specify as a user, that you must specify as a user, are secrets. Things like passwords, certificates, and so on. HSM has the ability to generate all of these for you. Of course, we could have specified each one, each certificate, each password, each secret, but we don't. We just automatically generate those and move on. So it's a bit of a value add on top of Kubernetes. If you weren't using HSM, you would have to specify all of these secrets manually. Still, it would be a lot less than all the properties you find in a BOSH deployment manifest, and they're kind of easier to deal with because they're environment variables. So you could take each image and Docker run it manually. If you think about it, there's no other way for you to actually run each component of Cloud Foundry manually without resorting to BOSH. So this gives you an alternative. There's also another helper file here, which we call opinions. This looks like a BOSH manifest as well. This is basically a collection of values that you as a let's say vendor of a Cloud Foundry distro, you feel that the defaults that Cloud Foundry comes with are not proper and you want to change them. So these values will actually be baked into the image that you deploy to the end user, and you can override them here in this opinions YAML, and Fissel will embed them in the image for you. Okay. Let me quickly check to see if there was any progress on our HCF deployment. It looks like not yet. So I will move on to the next part of the presentation. Apparently the deployment is taking longer to deploy. Apologies for that. I was basically going to show you me targeting to the deployment, creating an app, creating an org space, and so on, and hooking up to a service that's deployed on the same control plane. So I'm going to. So I talked about CFSolo, and please, if you get a chance, go to these projects. You can run CFSolo very easily on a Linux machine. It's literally one command line, and it runs all of Cloud Foundry in one container. And you should be able to target it, deploy apps immediately after that. It's based on Cloud Foundry version 2.4.1. And if you like this idea of being able to run all of Cloud Foundry in one Docker container, please let us know and help us make this thing better. There's also a channel on Cloud Foundry Slack for Fissel. Okay, so the final piece, a thing that we call Furnace. So we've just established that we're running Cloud Foundry on top of Kubernetes. And if you think about it, we still have Diego release. So question is, are we running containers in containers? Yes, we are. Basically, garden containers, which are the way that Cloud Foundry deploys applications for you, they run inside the Docker containers that get deployed by Kubernetes. And this works fine. We haven't seen any performance issues. But why do this? Why run containers in containers? The obvious next question would be, why not deploy Cloud Foundry apps directly on Kubernetes, since you already have a Kubernetes? And it's a good question. So we started an experiment together with IBM to try and make the scheduler in Cloud Foundry pluggable. So this would mean, if you're familiar with Cloud Foundry, the current scheduler is called Diego. And we just wanted to put an abstraction layer in the middle so we can swap it out for something different. And of course, what would be a good first alternative implementation other than Kubernetes? So we did this, and it's experimental work only. It's not part of the HCF distro that we've tried to deploy, but it is demoable. So I'm going to give you a demo of a Furnace right now. Hopefully you can see this. Okay. So what I'm going to do now is deploy the Dora app, which it's a reference application that the Cloud Foundry community uses to test Cloud Foundry deployments. And this is going to get deployed on a local BOSH Lite deployment of Cloud Foundry that has this Furnace project embedded into it. So I'm just going to do cf push Dora. OK. And we should see in about a few seconds some logs coming up. These already don't look like the normal logs you would see in a Cloud Foundry deployment. And it's because the staging is actually happening inside a Docker container on Kubernetes. So if we quickly switch to our Furnace dashboard, we'll see that we have a job here. This job is 26 seconds old, and it's running staging for us for the application that I've just deployed. So moving back, we're downloading stuff here. We don't have caching yet, so every time we deploy an application, it actually downloads all the build packs, tries to figure out which build pack to use to deploy, and then actually deploys the thing. So if you noticed, logs also work. So the whole log aggregator system works as well. And we got an application running. So how does that look like? So if we refresh, we should see a new replication controller here, which is 29 seconds old. If you look, the image that's used for this running application is CF Linux FS2. So it's the Docker equivalent of the rootfs image that comes with Cloud Foundry. So let's just see if this application works. And it does. So this is running Buildpack-based applications using Cloud Foundry on Kubernetes. But as you're probably aware, Cloud Foundry can also deploy Docker-based applications. So this is actually interesting. If you do something like push a Docker test application, this is a very small node-based Docker image. This is really cool. The staging part, because it's Kubernetes, is a no-op. So it's really fast. So for the staging part, normally Cloud Foundry has to download the Docker image. It has to upload the image to a blob store. Then it has to come back, and so on. For us, for Kubernetes, we actually do nothing. It's a no-op. And then we just pass on through and tell Kubernetes to run the Docker image that we want. So as you can see, it's pretty fast. Let's see if this one works. And it does. OK. So let me give this another look. OK. So we're not going to see that HCF come up. Sorry about that. But these are basically all the pieces that we wanted to show. You can see here that we've completed the work to run Cloud Foundry on top of Kubernetes. It runs well. It's a fully Cloud Foundry Foundation certified distribution. And we're also thinking about ways to make the whole thing simpler by trying to deploy applications on top of Kubernetes, not doing containers in containers. Of course, there's still a lot of work to be done there. Kubernetes doesn't have all the features necessary to have 100% parity with with the capabilities that Cloud Foundry has today, but it's definitely something interesting. So thank you, and if there are any questions, we'd be happy to answer them. Go ahead. The storage, so the question was, how do we manage the storage of the application when things get deployed on Kubernetes for the Furnace project?
Yeah, for example, if you have an application that needs file system, cluster file system, and
Oh,
you would deploy it as Cloud Foundry application, and Cloud Foundry is already deployed on Kubernetes.
okay. So first, the GlusterFS system is for the control plane. It's only available to distributed systems that get deployed exclusively through the control plane that we've built. And second, the Furnace project is just an experiment. It's not tied to Staccato in any way. It's just an experiment that runs off of upstream BOSH releases in BOSH Lite. So we don't have file system support for applications running in Cloud Foundry, if that's what you're asking. Those GlusterFS volumes are only used for things like Cloud Foundry itself, not applications in Cloud Foundry.
Yeah, I just wanted to know if you want to do that, how you will do it. Because
Oh.
Cloud Foundry supports file system.
Yeah. So the Percy project, we're working on that now, and we're looking at ways where we can use the GlusterFS support available in the control plane and leverage it in Percy.
So in that case, so as you said, Percy allows you to do that. So you just implement the private
Yes.
Cloud Foundry, but at the same time, Redis has its own support.
Right. So just to answer that question, the question is whether, if I'm getting it right, the Gluster pieces that we deploy, whether that's usable by the control plane at all. So for stuff that's deployed using the DSL that I was talking about, the service language, you can specify whether you want volume support or shared volume support. If you specify you want volume support, then we use volumes in the IaaS provider. So for example, you would get AWS provisioned volumes. If you say you want shared volume support for your application, then you'd get a volume on Gluster that you can attach to multiple containers in Kubernetes itself. So we make use of Kubernetes' notion of volume and shared volume to leverage either the underlying IaaS provider volumes or GlusterFS volumes in this case.
The latest release of Staccato is Cloud Foundry containerized, or is it still much of the
So the question was whether the latest version of Staccato is VMs or containerized Cloud Foundry. The answer is containerized. So Staccato 4.0 has containerized Cloud Foundry. Okay, thank you.